Hello students, in the previous lecture we have started that new chapter biomolecules. Lifeless molecules which combine in a specific manner to produce life are known as biomolecules. There are other lifeless molecules. For example, carbohydrates, proteins, fats, lipids, hormones, vitamins, nucleic acids. And in the previous lecture, we have started carbohydrates. We have completed definition of carbohydrate and then classification of carbohydrate. That much part already we have studied in the last lecture. Now, carbohydrates, polyhydroxyaldehydes or polyhydroxyketones are known as carbohydrates. Polyhydroxyaldehydes or polyhydroxyketones are the compounds which are hydrolysis. Gives these means polyhydroxyaldehydes and polyhydroxyketones are known as carbohydrates. Glucose, fructose, sucrose, raffinose, stachyose are the examples of that carbohydrates. Then after that, classification of carbohydrates on the basis of number of simple molecules or monosaccharide molecules obtained on hydrolysis. That carbohydrates are classified as monosaccharides. Monosaccharides are the, what are monosaccharides? Monosaccharides are the basic units of the carbohydrates. They cannot be hydrolyzed, they cannot be further hydrolyzed. Or the carbohydrates which do not undergo hydrolysis, that type of the carbohydrates, or that cannot be hydrolyzed further, are known as monosaccharides. Glucose, fructose are the examples of monosaccharides. Then oligosaccharides, the carbohydrates, or the carbohydrates which are hydrolysis gives 2 to 10 molecules of monosaccharides, are known as oligosaccharides. Examples: sucrose, lactose, maltose, raffinose. Then again they are classified disaccharides, trisaccharides and tetrasaccharides. Then polysaccharides, the carbohydrates which are hydrolyzed use many molecules or large number of monosaccharide molecules are known as polysaccharides. For example, starch, cellulose, glycogen, etc. Now we are going to see here first of all we will see here nomenclature of carbohydrates and then preparation of glucose. Here now, according to IUPAC system, simple monosaccharides are known as glycose. And always the name of carbohydrates ends with OSE. For example, glucose, fructose, sucrose, raffinose, stachyose. The name ends with always the name of carbohydrates that ends with simple carbohydrates ends with OSE. Now, in these simple carbohydrates, there are, in few carbohydrates there is aldehyde group, and if there is aldehyde group, that sugar is known as aldose. And if there is a such type of the keto group is there, that sugar is known as ketose. And from these functional groups, if there are totally 3 carbon atoms with that aldehyde group, then here I have given the number of carbon atoms. If there are number of carbon atoms 3, and that is aldose sugar. If aldose sugar means that contains aldehyde group, then the name of that sugar is aldotriose. Tri means it indicates the total number of carbon atoms ending with OSE, and aldo means aldehyde group. Aldotriose. If there are 3 carbon atoms and keto group is there, that is known as ketotriols. Similarly, if there are 4 carbon atoms, then it is an aldehyde group is there, that is known as aldotetrols. If keto group is there, that is known as ketotetrols. And if there are 5 carbon atoms and aldehyde group is there, that is known as aldopentones. And if there are 5 carbon atoms and there is keto group, that is known as ketopentones. Here now, if there are 6 carbon atoms, then and if aldehyde group is there, that is known as aldohexose. Glucose is nothing but an example of aldohexose. The name of glucose is aldohexose sugar. And if there is a keto group, 6 carbon atoms and keto group, that is known as ketohexose sugar, and that is the fructose is an example of ketohexose sugar. Now here we will see few examples. Suppose the structure I have drawn another structure of. Here now it contains 3 carbon atoms. Here is aldehyde group, therefore it is nothing but aldotriols. Here it is keto group. Totally there are 3 carbon atoms. Therefore it is ketotriols. It is ketotriols. It is ketoaldols. In this way, the names of carbohydrates are derived. For example, suppose the structure is like this. Here is aldehyde group, then CHOH 3 times, and here CH2OH. Now here, what is the name of this structure now? What is the name of this carbohydrate? There are totally 3, 4, 5 carbon atoms. Means it is a pentose sugar. It is a aldehyde group. Therefore, it is aldopentose. It is nothing but the name of this sugar is aldopentose. In this way, ketohexose, aldohexose. Suppose the structure is like this: CH2OH, then C double bond O, then CHOH2, and then CH2OH. Now, first of all, we have to count the number of carbon atoms. Here 1, here 2 molecules, 2 here 2 plus 1, 3, 4, 5 carbon atoms. Therefore, it is a pentose again. Keto group is therefore it is ketopentose sugar. In this way, the IUPAC names of carbohydrates are derived. Now we see here preparation of glucose, preparation methods of glucose. In our new textbook, that includes 2 different methods from starch and sucrose. We will see first of all, we will see the preparation of glucose from sucrose, that is also known as cane sugar, and it is a laboratory method. By using this method, we cannot prepare glucose on large scale. Glucose, it is also known as grape sugar. It is also known as grape sugar, or this sugar is also known as dextrose, because naturally this sugar, glucose, it occurs in a dextro form. Therefore, it is also known as dextrose. It is optically active. Glucose, it is optically active, and it always naturally occurs in the form of dextro form. Therefore, it is also known as dextrose. It is also known as blood sugar, because the sugar which is present in the blood, that is also glucose. Therefore, these are the different names: glucose, grape sugar, dextrose, or blood sugar. Preparation from sucrose, that is also known as laboratory method. Now we will see here the formula of the sucrose is C12H22O11. This sucrose on hydrolysis, acid hydrolysis, it gives in the presence of dilute HCl. When it is heated in the presence of dilute HCl and alcohol, it gives. Now here it is an example of disaccharide. Sucrose, it is an example of disaccharide. On hydrolysis, it dissociates into, or it gives two molecules of C6H12O6 plus C6H12O6. Here now it is a balanced reaction now. 12 carbon atoms are here. C6 plus C6. Totally there are again here 12 carbon atoms. Now here 22 hydrogen atoms plus 2 hydrogen atoms of this water molecule. There are 22 plus 2, 24. Here 12 and here again 12 hydrogen atoms. C6H12. Then oxygen atoms, here Ln oxygen atoms plus 1, 12 oxygen atoms. Here 6 carbon atoms. Here 6 oxygen atoms and here again 6 carbon, 6 oxygen atoms. In this way it is a balance. And here it is a mixture of glucose and fructose. Now here, when this sucrose is hydrolyzed by using dilute HCl, then glucose and fructose is obtained. Now this reaction, if it is how will you prepare glucose from sucrose? Such type of the question that may be asked in the board examination for 2 marks. Then there will be a 1 mark for this balanced reaction, and then there is 1 mark for the separation. And now we have to separate that glucose from this fructose. Here now, during cooling, alcohol is added into this mixture. Then what happens here? Suppose we have taken that mixture in a beaker like this. Here is the mixture of glucose plus fructose. It is a mixture of glucose and fructose. And into this mixture we have added here alcohol. During cooling, alcohol is added. Now what happens here? Glucose is almost insoluble in alcohol or very sparingly soluble in alcohol. फार कमी प्रमाणामध्ये ग्लुकोज यूज होते. Therefore, but this fructose it is soluble in alcohol. Therefore, glucose is not soluble in alcohol. Therefore, it crystallizes out first. Therefore, it forms the crystals fastly. When glucose crystals लवकर तयार होते, it is insoluble in alcohol. And then we have to filter this mixture. And here now, after filtration, we will get here the crystals of glucose. After filtration, it is a funnel. Here again it is known as filtrate. Now this filtrate it contains only fructose. Now this solution it contains fructose. Here is fructose. In this way, if we have separated this by using this funnel, filter this glucose crystals are obtained here. In this way we can separate the glucose from fructose, and also we can prepare fructose. Now evaporate this filtrate, heat this filtrate strongly, evaporate this filtrate, then we will get again fructose. In this way we have to write the separation. During cooling, alcohol is added into this mixture. That mixture contains glucose and fructose. Glucose is almost insoluble in that alcohol, therefore it crystallizes out first, or it forms the crystals, and that crystals are separated by filtration. त्याला फिल्टर करा. या फिल्टर पेपरवरती आपल्याला क्रिस्टल्स वरच्या बाजूला असतील ते ग्लुकोजचे असतील, आणि खालच्या बाजूला जे लिक्विड येतं दॅट इज नोन ॲज फिल्ट्रेट, याच्यामध्ये फक्त फ्रुक्टोज आहे. नाव दिस फिल्ट्रेट ऑन इव्हॉपरेशन, याला इव्हॉपरेट करा, स्ट्रॉंगली हीट करत चला. That alcohol and the amount of water which is present here, that is to be evaporated, and then we will get pure fructose also. In this way, we can prepare glucose from sucrose. It is regarding about the first method of preparation of glucose, and it is a laboratory method. This This method, it is not used to prepare glucose on large scale. On large scale, glucose is prepared by using from that second method, from starch, preparation of glucose from starch, and it is we can manufacture glucose from the starch, and it is also nothing but it is a commercial method or industrial method. That is commercial method. Here in this method now, it is a commercial method. In this method now, we know the formula of that starch. That is, when starch, it is obtained from potato, beetroot, and that starch which is obtained from that starch we can manufacture glucose on large scale. Here now, when that starch is hydrolyzed by using formula of the starch is C6H10O5. हे लक्षात ठेवणं सोपं आहे. याच्यामध्ये प्लस H2O, एक H2O मॉलिक्यूल ऍड केल्यानंतर हे C6H12O6 व्हायला पाहिजे. हे C6 आहे, इथे 10 काय घेतो, तिथे 2 हायड्रोजन ऍड करायचे आणि हा ऑक्सिजन ऍड करायचा. म्हणून C6H10O5 प्लस H2 ऍड केल्यानंतर C6H12O6 झालं पाहिजे. हे नाव इट इज अ फॉर्म्युला ऑफ, इट इज अ स्टार्च. When this starch is hydrolyzed by using dilute H2SO4 at 393 Kelvin temperature, at 393 Kelvin temperature and under 223 atmospheric pressure, then these conditions are important. When this starch is hydrolyzed, here this N represents there are N molecules of starch. N नंतर लिहिणं आणि N कोणत्या मॉलिक्यूलच्या सुरुवातीला लिहिणं त्यामध्ये डिफरन्स आहे. When C6H10O5 N ज्यावेळेस आपण असं लिहितो पुढं, that indicates there are many molecules or number of molecules, but this N indicates they are linked or bonded with each other. But here now NH2O या यांच्या पोझिशन्स बदलायला नाही पाहिजे. N इथे घेतला आहे, इथे लिहित आहे N molecules of H2O. This indicates there are many molecules of H2O, but they are separate from each other. There is a meaning for this N. नंतर जर N लिहिलं असेल, that indicates they are bonded with each other. N जर असं सुरुवातीला लिहिलं असेल, that indicates there are N molecules, but they are separate from each other. It means that, and now this molecule, if this meaning of this N means like this C6H10O5, H10O5 as N molecules attached एकमेकांना, and that on hydrolysis gives here N molecules of now C6H12O6, and it is nothing but glucose. It gives pure glucose. There is no mixture of glucose. Here only we have to remember that in this molecule, in the first method, in the sucrose gives molecule of glucose and fructose. But here we will get here pure glucose when starch is hydrolyzed by using dilute H2SO4 at 393 Kelvin temperature under 223 atmospheric pressure, then glucose is obtained. Again, such type of the question that may be asked: how do you prepare starch? How do you prepare glucose from starch? Or give commercial method for the preparation of glucose. Then this reaction, it carries 1 mark, and there is again separation is important. For that separation, there is 1 mark here. Now for the separation here, now here we have taken here dilute H2SO4. It is used to hydrolyze that starch into glucose. But when the excess of acid, excess of dilute H2SO4, जे काही त्या H2SO4 ची excess amount असेल, जी की शिल्लक आहे त्यामध्ये आपल्या मिक्सरमध्ये, that excess of H2SO4 is removed by adding calcium carbonate. Calcium carbonate, or it is also known as chalk powder, or calcium carbonate, or it is also known as chalk powder. Now here it is a glucose. This mixture contains glucose plus unreacted part of that H2SO4. We have to remove that H2SO4 from that glucose, and that excess, to remove that excess of H2SO4, that glucose, that mixture is treated with calcium carbonate, that is chalk powder. Here H2SO4 which is present in that mixture, that reacts with this calcium carbonate and gives, it is to be converted into calcium sulfate, CaSO4. It is the precipitate plus CO2 plus H2O, CO2, that is the gas that is given out, and H2O molecules are also formed takes place here. Calcium sulfate, it is insoluble in the water. Calcium sulfate. Now this H2SO4, it reacts with calcium carbonate and to give calcium sulfate. Calcium sulfate मध्ये कन्वर्ट होईल आणि हे precipitate आहे, हे solid आहे. Then we have to filter this mixture. त्याला filter करा. We have to filter all this by adding this calcium carbonate. We have to filter all this mixture. Then we will get here now. After it is a funnel, there is a filter paper. Now we have to filter that mixture. We will get here calcium sulfate, and this beaker contains glucose now. This beaker contains glucose, and it is free from now H2SO4. आता याच्यामध्ये H2SO4 नाही आहे. Now, but if it is, here is calcium sulfate. Calcium sulfate is removed by filtration. त्याला filter करा. It is a funnel. या funnel मधून आपण filter केलं. Now here, this glucose, to prepare, to decolorize that mixture. Suppose now to prepare glucose in the pure form, or in the pure form, we have to decolorize this mixture. We have to add animal charcoal now. In this mixture there is activated charcoal. Add activated charcoal in this mixture. There is a activated charcoal. It is adsorbent. It is a adsorbent. Activated charcoal. We have to add activated charcoal into this mixture. If there is any color to this liquid, that color is absorbed by that charcoal. Charcoal म्हणजे हा एक टाईपचा असा कोळशाचाच प्रकार. तर त्या कोळशाच्या सरफेसवरती जे काही कलर नसेल तो कलर ऑब्झॉर्व केला जातो, अँड दॅट प्युअर कलरलेस लिक्विड इज देन इव्हॅपोरेटेड. आणि त्या प्युअर कलरलेस लिक्विडला इव्हॅपोरेट करायचं. देन आफ्टर इव्हॅपोरेशन वी विल गेट द प्युअर crystals of glucose. Now one where there are two methods, different two methods used for the preparation of glucose. First one is from sucrose. Formula, you have to remember the formula of sucrose and starch. Then here this N and here is N. N has तीन ठिकाणी आलेला आहे. इस पोझिशन्स बदलल्या नाही पाहिजे. Here C12H22 plus H2 will use C6H12O6 plus C6H12O6. That is preparation of glucose from sucrose. And in this another method, that is the laboratory method and the commercial method. When starch is hydrolyzed by using diluted H2SO4 at 393 Kelvin temperature and 2 to 3 atmospheric pressure, then N molecules of glucose are obtained. Now that the excess of diluted H2SO4 is removed by adding this chalk powder, then that H2SO4 that is to be converted into calcium sulfate. It is in the form of solid, it is in the form of precipitate. Then it is filtered and that calcium sulfate is removed, and here we get the filtrate, and we have to decolorize this filtrate by adding activated charcoal to prepare glucose in the pure form. We have to decolorize this filtrate by adding activated charcoal. That charcoal absorbs the color on the surface, and that colorless liquid is evaporated, and then pure glucose is obtained. With this we have completed methods of preparation of glucose. Today we stop here. Thank you.